Good afternoon. Today we're going to learn about TypeScript. So today's lesson is going to cover LC101 TypeScript, which comes from chapter 27 in the curriculum. Now there's two ways to follow along with today's lecture. The first is on Replit, feralw/LC101-TypeScript. That'll let you give a replit which you can run the code that we'll be using, and that'll build your code and run it all in once. So I could start it there. It takes a little bit, but you can see it printed out there. The other way to follow along today's lecture, and what I would recommend and what I'm going to do, is by this GitHub. So by cloning down this repository and working locally within VS Code. So let's get into that one for now. So I'm going to come back here and remove my TypeScript folder that I'm working in, and I'm going to clone down the repository fresh. So now I'm in my folder and I'm in exactly where I need to be, and I will open up my LC101 TypeScript folder and we're going to start working. So before we start working, I'm going to do a quick tour of what all these files are doing. So the README is just an explanation of this is the project we're working on. The license is just saying anybody can use this code if they want to use this code. The other three files are actually doing something. So our index.ts, this is where we're gonna put all of our TypeScript code within this file. And then our gitignore, this is just saying, hey, these are all the files that no matter what, I don't really want to push up to TypeScript. I don't want to push up to GitHub, sorry. I don't want to push back up to this repository. So in this gitignore, I'm saying, hey, anything that's a JavaScript file, like don't push up. Other things you'd want in your gitignore is like any environment variables. So any files that hold environment variables or secret keys or Amazon keys or anything like that. Those are things you might want in your gitignore. The last file in this tour is the tsconfig, and this tsconfig and this index.ts, these are the files that you're going to worry about with TypeScript today. So index.ts is where you put all your TypeScript code, and then your tsconfig, this is a whole bunch of settings. Some are set and some are not set. And what these settings do is they tell the computer how to transform your TypeScript back into JavaScript. So whether you do all these settings, you can play around with them and work with them if you want. These are the base settings that come with it. But that says, okay, this is how I want to switch this TypeScript down into JavaScript. And that's what we're worrying about today is how do we write in TypeScript and run TypeScript, and how is that slightly different than JavaScript? Okay, running TypeScript. So there's two ways to run TypeScript on your local computer. The first is to compile it down to JavaScript and then run JavaScript. And the next way is just to straight run it. So we're going to go over the first way first. So if you do tsc in the same directory that your project's in, so in the same directory that has a .ts file and the same directory that you have a tsconfig, it'll compile your code from TypeScript to JavaScript. And nothing happened here, but if we come back over here, we now have this build directory. And we can show that happen again. So we can delete that directory, run tsc, and now we're going to have this build directory. And what tsc did is it went into the index.ts and it compiled it down to this index.js. So the code in index.js is going to really be close to mirror the index.typescript code. A few notable exceptions are the types are in index.ts, but they're not here in index.js. One other way to run the code, if you don't want to make JavaScript, if you don't want, oh, hold up one second, take one step back. That just compiles the code. So tsc, all that did was transform index.ts into index.js. That doesn't actually run the code. So if we wanted to run the code, now we need to run this index.js file. So we come back over here and we say, hey, I want to run the index.js file. And it'll run through the file. In our case, it's printing out hello world and hello Shayla. And we come back to index.js and we set a variable, set another variable, print hello world, print hello Shayla. And that's one way to run TypeScript. I'm going to do it one more time. So if you have an index.ts file, you can run tsc. What ts is going to do is going to compile that TypeScript into JavaScript and store it. And then if you want to run that JavaScript, you can say, hey, run me that JavaScript file. And it'll run that file in the command line. If I'm going to change something here, so I changed here. I'm now saying hello, whoa, right? Whoa. And I say, hey, run that file again. It's not going to change. Even though I came here, I saved it, I came back and ran it. And that's because I changed the TypeScript file. I didn't change the JavaScript file. And if I want to change this JavaScript file, after I change the TypeScript file, so I change index.ts, I need to come back here and say tsc. And I need to recompile that JavaScript or that TypeScript into JavaScript. So now I come back and my index.js has all this compiled JavaScript, and I run it again, and then I'll actually see those changes. When I'm developing, there's actually a tool that I like to use which you might find helpful, and that's called tsnode. So if I do tsnode version, it's going to print out version 841. And if you do tsnode -- version and it says, hey, I can't find tsnode, you might have to say, hey, npm install tsnode. And if you get another error that says, I don't know what TypeScript is, you might have to npm install TypeScript locally. So once you have tsnode, you can actually use tsnode to skip that whole build and running stage, and you can say, hey, I want a tsnode and I just want to run my index.ts file. And that's going to compile it and run it in the exact same step. So you don't have to have this build folder. So now in this I only have my index.ts. I don't have any build folder. I don't have any index.js. And I can say run my TypeScript file, and it'll just straight run it. And then if I make any changes, I change this back to hello world, save it, run it, it'll immediately show up there. So I like to use tsnode because it'll compile and run in the same exact command. But for our purposes, tsnode is the same as tsc node. Those are the exact same things. If you run tsnode, it's the same as running tsc and then node in the same command. So that's how you get started and kind of start running TypeScript files on your local computer. Now let's dive in a little bit about the differences between TypeScript and JavaScript. And we'll just work through a few examples of that. So here on lines 1 through 7, we have almost the same thing, right? We have a JavaScript declaration, and that's how you declare a variable in JavaScript. You're saying const, my cat's name is Garfield, so here is my variable. I'm assigning it to the Garfield value. TypeScript is going to be very similar. We're saying, hey, here is my variable. I'm assigning it to this value. The only difference is that in TypeScript, we're going to say, here is a type. You are a blank. You are a string. I made a mistake there on line 5. I had capital S string, and we should be using lowercase s string. So I'm saying, hey, I'm creating this dog's name variable, but I'm saying it must be a string, and then I'm going to print that out to the console. And that's what we saw happen there. If I'm going to say this is a string, and I try to assign it to a number, two things are going to happen. The first thing is VS Code is going to complain. So my code editor here is going to say, hey, type 7 is not assignable to type string, and it's going to say, I'm kind of angry at you, I'm showing you a red line. And the other thing that happens is if I try to run the file, it'll break. It'll say 7 is not assignable to string. Like you're trying to give me a number, and you're calling it a string, and those two things don't compile. Whereas up here on line 2, I could have said, yeah, that's a number. Who cares? Because I didn't say what type it was. So now we have line 5 working. We're saying that it's a string, and that's how we're declaring a single variable and setting it to a value. So before we move on, we just run it again to make sure it compiles and runs. It does. And I'm going to clear my terminal so we can go on to the next example. Line 9. A function that takes the average of two input parameters. So let's create that function. In JavaScript, it would look something like this, right? And then you would return so a function taking in two input parameters, and then it is going to return the average of these two. TypeScript is going to help us out a little bit because it's saying that, okay, when you declare a function, you need to strongly type the inputs and the outputs. So in this case, it's saying input 1 is declared, but its value is never read. And it's saying input 1 explicitly has any type, which is not exactly what we want to be going for. So what we're going to say is when we provide a parameter to a function, we're going to specifically say that is a string, or that is a number, or that is an array. So these inputs, and those red squiggly lines start going away, are specific things. Oops. It was making me just give my function a name. The next thing we want to do is give it a return value. So first we want to say you have parameter values, and whatever you're returning, I expect it to be a number. And it'll also give this red squiggly line if we say, hey, I want to return potato, it'll say, hey, you know what? You can't return a string because you told me you were going to return a number. So you can't return a string. And then if you return a number, even if it's not doing any averaging, but you return a number, then it's actually going to let you, it'll stop complaining. It'll stop giving you this red line. So if we return a string value and try to run it, it's going to complain. It's going to say, hey, you told me you're returning a number, you're giving me a string, that's bullcrap, I'm not going to compile. But if you return a number, it'll say, okay, you know, it didn't throw me an error. I did compile, you just never called your actual function. So if we were to take the average of 7 and 11 and console log that average to the console, it's saying, hey, I got 7. Because average 7 and 11 returned 7 from the function, which is stored in line 18, which printed it out. And then once we have this compiling, now we can actually implement this average function, which should be input 1 plus input 2 divided by 2. And now it prints out 9 correctly. It did average those two. As I realize this, there's 2 more points I want to make. The first is on line 18, I made a mistake. I didn't give it a number. I didn't say, hey, you are a number. And in TypeScript, every time we declare a variable, we want to say you are a number, or you are a string, or you are an array, you are some type. So I can run that again, and it's not going to change anything, But the reason that this is helpful is if I expect this to be a number later on, but for example, a function changes way up here. So if this function changes and now it starts returning a string, but I didn't have this saying I need a number every time, it would fail. So if I say, hey, now we're going to start returning a string, average will still work. It'll say, okay, yeah, I can return a string, but now line 19 is complaining and saying, hey, you told me I was going to be a number, but now you're making me a string. So we'll put this all the way back to what it is. So now we're saying, here's an average, give me a number, I will return you a number, and then when we call that function, we're saying what I returned out of it, I expect that to be a number. So what happens if you provide a parameter that's different than what it expects? So if we say, hey, I'm going to give you a 7, but I'm going to make it into a string. VS Code is going to complain. VS Code is going to say that's a red squiggly. Argument of type quotation 7, that's not assignable to parameter type number. It's not the same thing. And if we were to try to run it, it's going to also throw us an error. It's going to say unable to compile. Argument of 7 is not the same as number. So if we want it to be happy, get rid of the red squiggly, we can say, okay, here's my average. All right, let's do 2 more examples. Write a function that returns a dog age from a human age. So we could say function dog age calculator, and that's going to take in a human age, which is a number, and it's going to return another number, which is a dog age. The function's complaining right now because it said, hey, you told me you're going to give me a number, you told me you're going to return a number, but you're not really returning anything right now. And to get a dog age, you can take a human age and you can multiply it by 7, and that's going to give you a dog age. So we declared a function. We're saying, give me a human age, which is a number, and then I'm going to return to you a dog age. And so what is my dog age if my dog is 7 years old? Come back here and I can run the file. It's going to say I am 49 years old. And likewise before, if we're trying to say, give me a string, it'll complain. It'll say, hey, you're giving me a string. You're giving me a string of 7 where you told me you would be giving me a number. And that's not the contract that we agreed upon. Using the keyword any. The keyword any in TypeScript is a cheat. So if we're going to go here in lines 23 through 27 and use the keyword any instead, that's kind of like us cheating to say I want to write this function, but I'm kind of lazy and I don't know the types right now. So you can use any whenever you want instead of a type. So if you don't want to say this is a string or this is a number, you can say, hey, I'm going to give you any. And then it's going to take a number like it does here in line 27. But it's also going to take a string, because a string, instead of being a red compiler error now a string, that matches any. Like, that's okay. So you can get away with it, but it doesn't always work. So for example, if instead of multiplying something by 7, if we were going to say, you know what, I just want to add it together 7 times. 1, 2, 3, 4, 5, 6, which is the same thing here. It can give us different results. So it gave us 7, 7, 7, 7, 7, 7, 7, whereas if it's a number, it'll give us 49. So that use of the keyword any, it can be useful if you really have to get something done But essentially what you're doing there is you're losing all the benefits of TypeScript. You're using the ability to say, hey, I want this to be a number or else something might go wrong that I don't want to go wrong. So that's how you use any. In my opinion, you want to avoid any at any cost. You really want to just not use it unless you're absolutely forced to. Okay, I'm going to leave the stretch challenges here. I'm going to leave 33 through 46. I'm going to leave them for extra work, for extra practice. And I'm just going to go through a little bit with like type aliases and union types. So I can say I want a printer function. And all this printer function is going to do prints the input to the console. So what this could happen is I could say, okay, give me an input. I don't care what that input is. And then all I want to do is print that input to the console. And so what this function is doing is it's really not, it's just like JavaScript here. It's saying you can give me anything you want, and then I'm just going to print that thing to the console. And I can call it with 3 and run it, and it'll just print 3 to the console. Or I can call it with potato, and it'll just print potato to the console. Now, one thing we can do is if we want to say let's add some restrictions on this, we can say only prints numbers and booleans. Right? So how do we do this? We could say, okay, input, that's going to be a number or a boolean, right? So I will let you give me a number or I will let you give me a boolean. And I do that by saying this thing you're giving me is a number and then this, pipe here or boolean. So that means potato is going to fail because string is not a number or boolean. But if I say 7 or 8 and run it, it'll work. If I say true and run it, it'll work. So it'll allow multiple types. So if you really must allow multiple types instead of using the keyword any, which is kind of lazy, you can say, okay, types are okay, but I want them to be one of these few specific types. Then the last thing I'll mention before we close the lecture here is on line 33, the void keyword. That means that nothing is being returned from the function. So you're just performing a side effect and executing something, but you're never returning something back. Whereas I'm going to return something here. It's going to give me a squiggly line. It's saying, hey, you're returning me a string, but you told me it was going to be void. You told me it was going to be nothing. So that's not allowed. If you're going to return void, then you just need to return. You can't give it something. You can't even, oh, okay, it'll let you give undefined. It won't let you give null. So void is really saying you're returning undefined from a function. Or you're just returning from a function, or you're just letting the function execute. You're not returning anything. That's our lesson on TypeScript. If you have any questions, definitely reach out in Slack or reach out to me or your TF or just the general help channel.